Hello students, today we will going to see how to do an assembly of a solid muff coupling. This is a simply assembly of solid muff coupling which consists of three different parts: the shaft with the quantity 2, muff with the quantity 1, and taper key with the quantity 1. Now listen carefully. Here they are using a taper key, but for my assembly I am using a simple rectangle key, and here are the dimensions. Now, as this is a confidential drawing of XYZ company, that's why I am deleting or hiding some component dimensions, and I am changing the some component dimensions so to keep their privacy. So that's why instead of taper key I'm using here as a rectangle key. This is simply the hello muff. These two are the shafts of a same dimensions, and here I'm using as a rectangle key rather than a taper key. So let's start to do an assembly. As I told you in my previous video, to do an assembly we require a parts or we require the elements. Okay, so again go the start mechanical design, go here as assembly design, and simply call the components or parts one by one. So I'm using this toolbar, that is product structure tools. In this toolbar I'm selecting the existing component 1, single click over here and single click on the product 1 to browse a component. So I'm selecting the first shaft one, say open. Now this is shaft on the screen. If you want, you can rotate or translate by using a manipulation one, or if you want you can keep as it is, or secondary you can simply rotate your screen like this. So choice is yours. Okay, so what I will do, I will simply rotate in this directions, maybe in this direction like this, or I will rotate like this. So choice is yours. Clear? Now if you want you can keep as it is, no problem. Okay, say okay. Now I will call once again the second shaft. Here we have two shafts, and the two shafts are axes are collinear or in the same line, see, and the two faces, the chamfer faces, are coincide with each other. So for that I'm again calling the one more shaft, that is the same shaft again. Okay, now this is a shaft. I'll simply use a manipulation one, and I'll simply move this on the other face. X is the direction, so I move in this directions, no problem for me. Okay, now if I want I can rotate this, no problem. So you decide how you want to rotate or how you want to translate the same things, so you can do this one. Okay, now this is the things. Now if I want to move this in this direction, so here is y direction, so I am moving the same in the y directions like this. Say okay. Now the two axes of the shafts are linear one or in line, so for this I am using this coincidence one. So select this coincident constraint 1 and select the axis of two different shafts. If the axes are not visible, simply zoom in the component and simply put this particular cursor on the part and select the axis. Similarly for this one. Now see, here we get some relations, right? So to understand what a relation is, you simply click on this icon, which is update one, and the shortcut is Control U. Select this. Now in this way the axis of these two shafts are collinear. If you click over here on tree 1, you find the history. What we perform the first? We perform the first as the coincidence one. Okay, fine. Next we have to simply connect this face with this one. So for that, go with the second one, contact constraint, select this, select the first one, hold the control key, sorry if the selection is wrong, it is not possible to do one. So I'm selecting the ones again over here. First I'm selecting the entire face, right, and holding the control key, this one. Now see, again this comes over here, that is surface contact. Again click on the update one. Now see, these two are connect with each other. But if you look out to this particular assembly, the key slot are again in line, but here one is on the upper side and another one on the lower side. So the next one is to do these two key slot in line, either like this or either like this. So what I'm supposed to do, I simply rotate this shaft. How? I select this one. Now see, the white something's appear on the screen. Select this and simply try to rotate this. Now see, it comes. Say OK. Now go for this offset one. Here the selection is very important for the offset. First select this one, vertical one, and the second one, yeah, I think it is not visible, yeah. So I'm the secondary selecting this. I'll say 0, say OK and say update. Now see, in this way these two are again in line. So by using coincidence, surface contact and offset, by using these three commands, you make these two shafts assembly perfect. If you want to hide this dot, you can simply right click on this one and say hide from over here, or simply select this one, this, and say hide over here, like this. So two options are with you. Okay, now the next one is after this is to simply assemble the key in this key slot. So again call a key. Now keys comes over here. Now here the drawing, yeah, so this is a key slot one. It's 8 by 6.354. so the 8 face is directly matching with this particular face. Remember, the 8 face is matching with this one. So if you are unable to understand where is 8, where is the 6 point something, so do one thing only. Here we have this measure option. Select this measure one and select once and the second, yeah, this one is 8. Okay, so this face is going to be rest on this particular one. So select this offset constraint, select the first, and similarly I'm going to select the second also. See and say update. Now this is perfectly going to match with this. Which one? This one. Okay, now similarly let's try to again do with this with this also. Yeah, this constraint is fully redundant with this, which is already spared, means is already constraint, so no problem. Okay, I'll do the control set, means to delete this one. Okay, fine. Now what I'm supposed to do, okay, I'm again selecting, yeah, this one is 8. Let's check. Yeah, this one is 8. So I'm constraint or contact constraint between this one with respect to this. So select this, select the one and select this one, say OK. Now see, in this way it comes in line. Now here, so here the dimensions are hidden. So what I'm supposed to do, I'll do simply arbitrary, maybe a linear distance between these two. So go over here, offset constraint, define the distance between this first and this one. Yeah, it is 136. So what I'm going to supposed to do here, I'll simply give us a 36 over here. I'll say update. Okay, so it's required ambia 26. Say okay, it is still there required. We'll go with the 10. Say update. Yeah, see why I'm doing a trial and error, because the dimensions are unknown for us, as I told you, because this is confidential data, so dimensions are unknown. Okay, now we're supposed to check this distance is 10, right? Okay, this is perfect assembly. Now I'm supposed to check the distance, because I want to make this one equally specified on both the side. Yeah, it is 12, means we require one more, that is 11 over here. Now say update. Yeah, so on this side is 11, so also on this side we required 11, the same thing. So that is yes, use of the measure distance or measure between. So in this way we completed the assembly of two shafts with this particular key. Now the next part is to do an assembly of the muff, which is a hollow one. So simply call as a muff. Yeah, the muff comes over here. Okay, now this is like this. So without disturbing this one, I directly go with this one. Select this and select this. Yeah, see, now this appears over here. Fine. Now again, as per the drawing, this is 88. So what I'm supposed to do, I'll simply give again some distance, sorry, the offset constant distance between this face and between this one is a 40. I'll say okay. Yeah, now I want to check on this particular side is how much is distance. So go here, measure here and here. Yeah, it is 32. So I want to again check it at 36 and say update. Yeah, now again the check the distance between these two, one and this one. Yeah, again 36. Now it's perfect one. Because of the dimensions are not there, I'll do it with some trial and error, but the method is remains same. The maybe a coincidence, maybe the contact constraint, maybe the offset one. So like this you're going to perform this particular assembly over here, right? Now this is again displaced one, right? This is displaced with this, so again go with this one, offset constraint, this give us a 0. I'll say update. Yeah, see, in this way we can come up with the perfect assembly of this one, right? So this is a simple example of how to do an assembly of muff coupling. Here we have the two shafts, the one entire rectangle key and one is the hello muff, and these are the history. We simply give us whatever the things are there, those we have to perform, right? Okay, this comes because of some minor error, and because of this comes of the dimensions missing, right? So you take the appropriate dimensions and you can do the assembly at your end. Okay, so this is like this one. Okay, thank you very much.